Alright, Ex13F, question 13. So we've got a square base box, and we eventually want to find the minimum area. Okay, so I'll write the facts that I have. I know the volume is 256 centimeters cubed. What else do I know? I know it's a square base. That's about all I know. I'm trying to minimize the surface area. Okay, so I'll call the surface area capital A. So my goal is to get a formula for capital A. Okay, it's going to be affected by the length of the square and the height. Okay, so will be affected by the length L and the height H. So they use lowercase, I'll just use uppercase because the L's look too close to ones, so it's all good. Alright. Do I know any relationships between these variables? Well, I should be able to find the surface area. So the surface area of this thing unfolded, we've got a square with all sides L, and there's a rectangle coming off each of these squares of height H. Okay, and it does have, sorry, it's only an open top. Okay, so I don't need to put an additional one here. Alright, so there's one area, and the rest of these are all the same. Okay, so my area will be shape 1 plus 4 lots of shape 2. Area of shape 1 is L squared, and area of shape 2 is L times H. Make sure it's in alphabetical order. H-I-J-K-L, H-L. Okay, that's one relationship I know, the area relationship. I also know the volume relationship. So volume is area of the base times the height. I know the area of the base is a square, so it'll be L squared times H. And I also know that the actual volume is 256. Alright, so let's look at the actual questions it asks. Part A says find H in terms of L. Okay, so remember my goal is to minimize surface area. So I want to get rid of L or H from this first equation. So part A is literally just going to be getting H by itself in this equation. Okay, so that's part A done. I've got find the height in terms of, or as in a function of, L. H by itself, L on the other side, all good. Okay, part B, find the surface area A in terms of L only. Okay, at the moment I've got the surface area in terms of L and H. So the way I'm going to do part B is I'm going to substitute this expression I found in A into my surface area. Okay, so wherever I see H in here, I'll instead write 256 on L squared. 4 times 256 on L squared times L. Okay, I've just replaced this H with 256 on L squared. And I can do some simplification here. 4 times 256, 1024. L divided by L squared. So L on L squared is like L times L. So I'll have cancel. I've just left over 1 underneath. Okay, so 124 on L. I know I'm going to be differentiating it, so I'll write this as 1024 L to the minus 1. Okay, so part B is done. The surface area A in terms of L only. Here's the surface area A in terms, or as a function of L only. Okay, part C, the dimensions of the box if the surface area is to be a minimum. Okay, so I'm into my differentiation. So the minimum occurs at dA dL equals 0. So I need to differentiate A and find what dA dL is. So L squared 2L, and this one minus 1024 L to the power, subtract 1 from the power, minus 2. Yep, and I need to set this left hand side equal to 0. Okay, I need to solve this for L, so heaps of different ways you can do this. I'd probably rewrite this as that with L squared on the bottom, and multiply both sides by L squared to get rid of this fraction on the bottom. Okay, so 0 times L squared is 0, 2L times L squared is 2L cubed, and multiply by L squared here gets rid of that fraction. Okay, and you're just into equation solving mode now. 2L cubed 1024, L cubed divided that by 2 is 512, and L will be the cubed root of 512. The cubed root of 512. 8. Okay, 8 times 8, 64 times 8 is 512. Cool. So L equals 8. Taking the cube root, should I take the plus or minus cubed root? Nah. Okay, because minus 8 times minus 8 times minus 8 will give you negative 512, which isn't 512. So minus 8 isn't an answer here. Okay, so L equals 8. I'm not sure whether that's a maximum or a minimum, so I better classify my turning point. So I'll have the L values, dA, dL, and my slope diagram. So I want to investigate 8, and either side of it I may as well just pick 7 and 9. Okay, and I'm going to evaluate the slope at these 3 points to see what's happening around the point. And L equals 8, so I need to substitute 7. This will be dA dL when L equals 7 into that slope function. So 2 times 7 minus 1024 times 7 to the power minus 2. Times 7 minus 1024 times 7 to the power minus 2 minus 6.9. Okay, that's a negative value. We don't actually care about the number. This could be minus 0.0007. Still put a negative down there. Just care about the slope. I could probably just cheat and write a 0 in there for the 8, but this is a good check. Make sure I haven't made a mistake in my equation solving. Sweet. 0 flat line, and substitute in 9 as well. Okay, so at L equals 8, there is a minimum. The dimensions of the box if the surface area is to be a minimum. So I've found the length. I also need to find the height. Through this massive page, I can see in here I've got a equation for the height. Okay, so to find the height, sub L equals 8 into H equals 256 on L squared. Okay, so I'll just put an 8 in there, 256 on 8 squared. I think that's 4. Okay, so the dimensions are length of base is 8 centimeters, active centimeters. How do I know it's centimeters? Because all of this is in centimeters cubed. Length of base is 8 centimeters. Height is 4 centimeters. Okay, done. I found the dimensions. Part D asks for the minimum area. So I have a formula here for the area in terms of L. Okay, so I'll use this formula to find the area given that L is equal to 8. Okay, so I'm going to substitute L equals 8 into A equals L squared on the same page. L squared plus 1024 L to the minus 1. Okay, so we'll do that. I'd normally do it underneath, but I always run out of room. Okay, plug this in. Okay, so the minimum, not volume, surface area, is 192 centimeters cubed, centimeters squared. Okay, so what we've done is we've found the dimensions that will use the minimum surface area. So it'll only use 192 centimeters squared of material to make a box that has a volume of 256 centimeters cubed. Okay, we want to store 256 milliliters of Coca-Cola in a box using the smallest box. The way we can check that our calculus was correct is once we find this function here, okay, or the one with the negative power, we should put it into our calculator and graph it and see what it looks like. Okay, so just into graph mode. I'm I'm pretending that this is y and this is x, okay, because it's the way my graphics calculator does it. So y equals x squared plus 1024 times x to the power minus 1. Okay, you can put in that top formula if that's one you prefer. Draw it, I can't see anything. Shift zone auto normally does a pretty good job. Yeah, not too bad. Well, I didn't put that in right. X squared. That's 1024. Oh, yep. Okay, so shift G-solve. See if there's a minimum anywhere. Not found. Great. I'll just try putting in that other function just to check that my calculator is working properly. Like that, it's the same. Pause the video, figure out what's going on. Okay, so not sure what happened with my calculator, because when I graph it, looks completely different to what Desmos graphs it as. So we can see on Desmos, we'll probably even highlight this for me. No, all good. So I can zoom in. At this point here, 8192 is where the minimum is. You should be able to do a similar thing with the calculator. Not sure why you can't, but you just draw an image of what this looks like on your exam paper and show that as a check. Okay, get your communication justification points. Okay, that's the end.